everyone. Today we will continue our lesson uh, about the sun, earth, and the moon. We stopped last time at this page, seasons. So this time we will be talking about seasons. Okay, what causes the four seasons? As you can see, this page 303. And we will talk about patterns in the sky. And as we said previously, you can click on this button so you can hear the lesson. Okay, and we will start with the digital lesson. Okay, this page, by the way, is very important. Seasons page, this one. This page is very important page. Okay, let's go back to Think Central. How do the sun, earth, and moon interact? And let's see this page. Okay, let's listen.
As you know, Earth moves in another way while it turns on its axis. Earth also revolves around the sun, which takes about 1 year. During this time, the tilt of Earth's axis causes parts of Earth to receive different amounts of energy from sunlight. Areas that receive more direct sunlight are experiencing summer. Click the play button to learn more about the seasons.
Okay, before we click the play button to know more about the seasons, I'd like you to pay attention for very important thing in this slide. Notice that we have 4 positions of Earth during this year, and the movement, it shows the movement of the Earth. We call this movement, do you know what do we call it? Revolution. Yes, revolution. Right. Now, at the same time, Earth rotates on its axis. Let's see this one. This is the axis, an imaginary line, and the Earth rotates on its axis from west to east, as we previously mentioned. The other thing you have to keep in mind that Earth is divided into 2 equal spheres. They are called hemispheres. So this is the north hemisphere and this is the south hemisphere, northern hemisphere and southern hemisphere. Okay, this is very important. This line is called the equator line. So let's see this one, for example. This is the equator line. This is north, this is south, this is the axis, and notice that the axis is tilted. Okay, I'll do it the other way. So north, south, and this is the axis, and as we mentioned before, the axis is tilted. This tilt is very important because the Earth receives different amounts of light on both hemispheres. For example, this one, this part, it is tilted more. This part is tilted toward the sun, and this is the sun. So it receives more sunlight than the south, as you can see, north, south. You can see? So it receives more sunlight. The part that receives more sunlight experiences summer. Okay? The part that receives more sunlight experiences summer, while the part that receives less sunlight experiences winter. Okay, keep it in mind, and let's start looking at this slide. Please, we have 4 positions. 1, 2, 3, 4. This is the direction the earth moves or revolves around the sun. And listen up, please.
At this point in Earth's orbit, the northern hemisphere, the northern half of Earth, is tilted toward the sun. This area of Earth receives more direct sunlight than the southern hemisphere, which is tilted away from the sun. So, it is summer in the northern hemisphere. Now Earth has traveled about a quarter of the way around the sun. The northern hemisphere begins to be tilted away from the sun, and fall arrives. About halfway through Earth's orbit, the northern hemisphere is tilted away from the sun. This area of Earth receives less direct sunlight than the southern hemisphere at this point. So, it is winter in the northern hemisphere. At this point in Earth's orbit, the northern hemisphere starts to be tilted toward the sun again, and Earth begins to receive more direct sunlight. So, it is spring in the northern hemisphere.
Okay, so here we have summer in the northern hemisphere. Why summer? Because the northern hemisphere receives more sunlight, so it experiences summer. What comes after summer? Yes, fall. We're still talking about the north hemisphere. Okay, this position number 3. Okay, the north hemisphere is tilted away from the sun. It's away. So it receives less sunlight. So it is winter. At this position, after winter becomes spring, because both hemispheres, as you can see, they receive equal amount. In these two positions, just this is an information for you. These two positions, both hemispheres, they receive the same amount of sunlight. So it could be spring and fall, or fall and spring. It depends on the hemisphere. Okay? Repeat this slide again and again. You will understand it. And if you have any question, please let me know. Next. Okay, let's see the book. Okay, as you can see here, it shows the revolution around the sun. We have position 1, 2, 3, and 4. So, for example, the north hemisphere in position 1, here, north and south, they receive the same amount of sunlight, so it's fall. North hemisphere is winter, because as you can see, it's very obvious. This is the equator line. Okay, so this part is tilted away from the sun. It's far away from the sun, so it receives less sunlight, so it experiences winter, while at the same time the south or the southern hemisphere receives more sunlight. So what do you think it experiences? Yes, summer. You see, it's the opposite in both hemispheres. Okay, let's see this position. In north it's spring, and this position in north it is summer. Look at the tilt. Okay, the north is tilted to the sun, so it receives more sunlight than the southern hemisphere, which receives less sunlight. So in the north we have summer, and in the south we have winter. That's right, and so on. Okay, now let's see patterns in the sky. You don't have to memorize these patterns in the sky, but you have to know them, and they are called constellations. Okay, or constellation. Let's see this constellation here. As you can see, it's a group of stars. They form an imaginary picture or design, okay, in the sky. So let's answer this question before we go to the patterns. Listen up, please.
Choice best describes what causes day and night. Click your answer. Good.
Okay, what causes day and night? Moon's orbit around the sun, Earth's orbit around the sun, changing of seasons, Earth's rotation on its axis. Yes, whenever we have day and night, so it means day, and night, it means rotation on its axis. So this is the best choice.
Good job.
Yes.
As Earth revolves on its axis, your location on Earth moves from day to night.
Okay. Next.
When you look up at the sky at night, you probably recognize the Big Dipper. Throughout history, people have made up groups of stars called constellations and used them to make maps of the night sky.
Okay, now they're talking about constellations, group of stars in the sky. They form a pattern or they form a picture. It's an imaginary picture, it's not a real one. They used it previously and now they use it as a map in the sky that tells them about the directions, tells them about the season. Okay, listen.
The Big Dipper is part of Ursa Major. Ursa Major appears to move through the northern hemisphere sky all year. Click to learn more.
Okay, let's start from this one. And as I mentioned before, you don't have to memorize them. Okay, let's see this one, then this, then this, this. Try just to remember their names because we have a question about this constellation at what season they appear, in summer or other seasons. So which three appears in summer or two? Let's see.
Here we see Perseus, another son of Zeus. This constellation is best seen in December in the northern hemisphere. Here we see the constellation Auriga, or the Charioteer. This constellation is most visible in December. Many constellations are named after great heroes and people in myths. This constellation is called Gemini, or the twins. To the ancient Greek, this group of stars resembled stick figures of two people, sons of the Greek god Zeus. This constellation is best viewed from the northern hemisphere in February. Orion is visible all year from the northern hemisphere. However, it is easiest to find during winter. The middle star appears blurry. But if you look at Orion with a telescope, you might notice that this star is really a cluster of stars within a nebula. A nebula is a cloudy place in space made up of dust, hydrogen, helium, and other gases. Stars are born in nebulas.
Okay, I'll talk about this one. This is very bright star. Bright star doesn't mean it's really bright because it is a single star. It is group of stars that they look one star far away. They look one star, and these stars are formed from something called nebula. They are formed in nebula. Nebula has gases. You will learn more about nebula in the upper grades, but keep in mind that not only one star that makes that shine. It could be made of many stars, like Orion. Next.
Taurus appears to move from the eastern horizon in September to the western sky in April. In fact, it is visible from the northern hemisphere throughout the year.
Okay. You don't have to memorize them, as I said before.
Today, astronomers know.
Okay, let's see about sun-centered solar system because we have some questions after these slides. Now, this slide is talking about sun-centered. What do we mean by sun-centered? It means that the sun is in the center of the solar system. Other planets revolve around the sun. Previously, they said that it is Earth centered. But they had evidences that proved that Earth is not in the center of the solar system. Listen up to this slide and you will find out why did they change from Earth-centered to Sun-centered. This is Sun-centered. Okay? Let's listen.
Know a lot about the movement of Earth and other bodies in our solar system. 600 years ago, however, people had different ideas. The invention of telescopes helped astronomers learn more about Earth's motion in space. Click the image at the top to begin learning more about how ancient astronomers and modern scientists study Earth and space.
Okay.
People have studied the stars for thousands of years. Early astronomers thought Earth was motionless because they saw the sun, stars, and other planets rising and setting across Earth's sky. Early astronomers thought these bodies revolved around Earth.
So they said that the Earth is in the center of the solar system. The sun, moon, even the moon. Look at the moon. Venus, other planets, they revolve around the Earth and it is motionless. It means that it doesn't move. Okay, how did they prove the opposite? Let's see.
Early astronomers did not have telescopes. Instead, they used tools like this one to measure angles. Early astronomers used this data to estimate how far away each star was. They also made maps of the constellations. Early travelers used the stars and constellations to help them navigate during their journeys.
Yes, the stars, they guided the travelers through their journeys. Let's see a little